Welcome. My name is Santiago, aka Sergeant Mindset, and we're going live on the human experience. So, quick background: I'm currently trying to get my master's in performance psychology, and right now I'm in a class called biological psychology. I'm on module 2 of that class, and I thought, why not share what I'm studying with everyone while I learn? So here we go. Bear with me. I'm just going to walk you through basically everything I just learned in the order that it actually started making sense for me. And some of this stuff was actually very interesting to learn. So I'm going to use some examples here. Okay, so we start here with this blank piece of paper. Because if you didn't know, you're this piece of paper. But for the sake of this video and what we're talking about here, you're this piece of paper. And 18 days after you get made, like in the womb, this is basically what you are. So the chapter opens up with development, genetics and development, and plasticity. And real quick, plasticity just means your brain's actual ability to change and reshape itself over time. Kind of like clay. Not like a rock that's stuck being the same shape forever. And that's literally the title of chapter 4 of what I'm currently working on and learning. The very first thing it walks you through is how you actually get built, right? Physically from nothing, back when you're still in the womb, before you're even considered a baby yet. I'm not just going to tell you this one. I'm going to show you because this is so fucking wild when you actually watch it happen instead of reading a paragraph about it or me just lecturing you on what it is. So, you start out as this flat piece of paper, basically a pancake. And who doesn't love pancakes, right? So, you start out, and the sheet starts folding up on itself, the edges lifting up and curling towards each other, like this. And in less than 4 weeks, it seals it shut completely. Let me see how I'm going to tape this. Okay, I'm just going to use these things that I've been using to tape up my board. As you can tell, one of my boards just fell. But yeah, let's just use this to tape up the piece of paper. We're just going to use 3 of them, just because we're not trying to go all out. We're just going to pretend like there's elevator music going on, you know. Okay. Uno momento más, por favor. Alright, so we got our stickers, right? So, again. This sheet starts folding up on itself, and the edges start lifting and curling towards each other. And in less than 4 weeks, it seals it shut completely. Boom. Bada bing, bada boom. Forget about it. Alright. Boom. Shuts itself completely. And I'm literally taping this closed right now because this is what your body's doing around day 25, maybe 27. Sealing this seam for good. And once it's sealed, this is the tube, is the only piece of material your entire brain and your entire spinal cord ever get built from. There's no separate ingredient list. It's just this. So, this tube right here in my hand, that's it. That's the one and only piece of material your entire brain and your entire spinal cord ever get built out of. There's no separate ingredient added later. It's this. And honestly, this is where it goes full transformer on us. This is one flat piece of boring piece of paper material, and it folded itself into the 3 completely different working parts right in front of you. So I'm going to be marking these just so you can understand the 3 parts that I'm going to be talking about. I'll just maybe I should have drawn this before, but we improvise. That's the human experience, right? Okay, making this happen for ya. Alright, we got 1, 2, a tree. Okay. So, I'm marking these off right now, which I did. And 1, okay, this part of you, this is what actually thinks and makes decisions for yourself. Okay? And then it's like, this is basically you. The 1 part is basically you. The middle one works more like a relay runner that's just passing between signals back and forth between the first and the third. And the last one runs stuff you never even think about, like breathing, balance, things that are keeping you alive without you doing a single thing on purpose. So all those other things like chewing and breathing at the same time, walking, moving your legs, your arms, doing, whatever you need to do. That's this. All right? That's the tube. Crazy, right? Okay, so once you're built, chapter 4 gets into genetics. And this is where it started getting into stuff I already use or talk about in a everyday life. I just never had like the vocabulary or the terminology for it before now, or the science to really understand it. And basically you get dealt a hand of cards, right? Let's use these Uno cards as an example. All right. You get dealt a hand of cards the day you're conceived. That's your genes. And you don't get a redraw. That's just what you got. But there's the part that actually hits, right? Having the card doesn't mean the card automatically plays itself. There's a whole field called epigenetics. And if you've ever heard that word before, all it really means is your environment can reach in and switch certain genes on and off without ever touching or rewiring the DNA itself. The gene was already sitting there the whole time. It just needs something to trigger it. Think of it like in Dragon Ball, right? Like Goku, he's a Saiyan. He's going Super Saiyan. And then Super Saiyan 3, or, God mode, or, Ultra Instinct. That ability was always baked into the DNA from the jump. Nothing about genetics changes the moment they transform or go to that next level. It just takes the right conditions, enough rage, enough near-death pressure, whatever it is for that thing to actually switch on. And that's basically epigenetics. The card stays exactly the same, whether it gets played hard or barely gets played at all. And that's its environment. Nothing about the card changes. This is the card you're dealt. Now, and for those that didn't get my Dragon Ball reference, there was an image in the chapter that they used, and they were like telling you to picture the development like a ball rolling down a hillside that already has grooves carved into it. The grooves are your genetics. They're already there before you're born. But which groove the ball actually rolls down, that gets pushed around by everything happening while it's rolling. So genetics builds the terrain. It doesn't drive the ball itself. So that was genetics. That was the genetics piece. And this next part that we're going to be talking about is the plasticity, which turned into the 3 things that I kept talking about. These things. Think of your brain like a tree, okay? If you know me, I love trees. I'll be posting about trees all the time. Think about it, trees, all right? Not the branches. We're thinking about the roots underneath, okay? The day you were born, you already got roots reaching out everywhere. By the age 3, you got 6 times more roots than you started with. 3-year-old you has the most tangled root system you will ever have in your entire life. More than you have right now. Watch. I'll draw this out for you. Okay. Think of it. This is the little tree that I have. Beep. Boop. These are the branches. Okay. Now, down here, these are the roots. Draw some squiggly lines. Roots, we got a bunch of roots. Okay, and this is what I was telling you, that by the time you're 3, you've got 6 times more roots than that. So imagine by the time you just get a bunch of roots coming out, bam, bam, everywhere. And then about half of that just gets cut, gone. And it's not random which ones either. The roots that don't hold, the ones that get pruned away, those are just the ones you didn't keep repeating. The ones that get used over and over, that you dig deep, get thick, hold the tree up. The ones that never get used dry out and the tree uses, like this. So, the ones that you don't use and you don't repeat, instantly, whoop, roots gone. The only ones staying are the ones strong enough for the tree to be held upright. Okay, so now let's put this over here. Now here's where genetics and plasticity actually collide. Okay, this is the part that actually started making sense for me. There's a disease called Huntington's. It's basically one glitchy gene, kind of in that Spider-Verse moment where Miles Morales starts flickering, glitching out because his code's not running right. Except this glitch never fixes itself. If you're born with it, that's it. That's the card already been played. It doesn't matter what you eat, how hard you train, you're getting this disease. There's no way around it. It's pretty fatal, locked in before you were even born. Okay? So, in what we were studying today, they took a bunch of mice all holding the exact same card, okay? Same gene, same guaranteed outcome, and stuck one group in boring, empty cage. Nothing to do, same 4 walls every day. And that group got sick fast, hit early, and hit them hard. So imagine, these are the mice, this is just the genetic code, they get put in this environment. Look how plain this is. There's 4 walls right here. It's plain, there's nothing else, okay? Then there was another group, okay, the exact same card, okay, the exact same card. Hold on. We're just going to draw a quick line down here, okay, same exact card, same guaranteed, but they lived somewhere with toys. I'm just going to put my fidget cube on here, maybe the sharpener, alright, right? Just gonna put the sharpener right there. With toys, stuff they can climb up, stuff to figure out, room to actually move. And that group, this group right here, they got sick way later. And once it did show up, it moved way slower. So it's the same card, but 2 different rooms. That's the only thing that changed. And it's very interesting to read because it's not some feel-good motivational guru thing I'm saying to sound deep. Like, that's a real experiment. Mice actually live that. And it means even something already locked in on paper still plays out completely different depending on what's around it day to day. So that's a piece of this is called the brain reserve 2. It's the same idea, but it's applied to stuff like Alzheimer's. Keeping your brain stimulated and moving actually builds up a reserve that protects you later. So it's not just don't get sick as bad, it's building a buffer before you even need one. And that's basically the whole thing. I've been telling people this whole time, just what actual numbers behind it now. It's not that people don't have what it takes, it's that most people are stuck in an empty room and don't even realize there's a different room available. You don't get to pick your card, right? But you always get to pick the room you go in. Okay, now, this part is crazy, because chapter 4, right, we talked about genetics, development, the plasticity, and that's basically the whole module on its own. But then we went into chapter 5. This week it was about vision, and It just sounded kind of lame. I saw a vision on the chapter title, and I was like, all right, this is like, I guess what you see, or I don't know, your eye. I don't know. I didn't understand it, but I thought it was gonna be boring. But it's the one that like shook everything for me. Like it made more sense on why I am the way I am and how I see things and I do things on my day to day life, I guess. So it's just I'm just thinking about it, and it's crazy. I almost didn't expect like to care going into it, and it ended up being like the wildest part. So real quick, how you actually see anything, right? Light hits your eye, it hits the back of it, the retina, and the cells back there aren't really taking like a photograph. They're mostly detecting edges and contrast. Okay. There's this like drawing that I've seen a lot in, like, if you ever go to an eye doctor, or I'm sure some people have seen it in science class. It's like this big circle, and this is your eye, right? And then they show you how light comes like this, right? Like what you're seeing here is not how you see it here. It's backwards, right? So that's just your eye detecting those edges and contrast. So the signal travels down to your optic nerve, and this is where the weird part, right? The two optic nerves actually cross over and part ways right here. This is where it part ways, like going into the eye. Oh, right here, I would say here, because technically it goes into your eye, your retina. Okay, so information from the left side of what you're looking at ends up getting processed on the right side of your brain, and the other way around. It's wired backwards from what you'd assume. I know most of you have seen that drawing, right? This is the drawing I was telling you about. So that signal passes through a relay station in the middle of your brain, and then finally lands in the back of your skull, in the visual cortex, and that's generally where seeing happens. Your eyes don't see anything, they just collect the light. Your brain is what turns contrast signals into an actual picture. And once in the cortex, it splits into basically two highways. One running up toward the top of your brain, okay, and mostly tracking where something is and how it's moving, and one running down toward the side that's mostly figuring out what something actually is. Its shape, its color, whether you recognize it. So your brain isn't building one picture. It's running two separate processing tracks and stitching them together so fast you never notice it's two things. Like for real, like can you even fathom how fast that actually has to be? Like right now, if you're watching me, it has to be so fast to know that I am a human person. You see these squares, you see my water bottle here, and it's like processing this so freaking fast so it can see it for you. Does that make sense? Like, that's crazy, right? So, this is the term that like completely fucked me up. It is crazy. And this term is called Aphantasia. And it left me a little bit off. I think if that's like the word I'd use, I can't find a good vocab word or terminology to like say how like eye-opening and mindfuck it was for me to like understand this concept. So, and it just makes so much more sense for me now, because it turns out that there's a chunk of people out there who, when you tell them to close their eyes and picture something, let's say an apple, their childhood house, whatever, they get nothing. And there's no image at all. Their mind eye is just blank. And I'm one of those people. Like, I didn't know, Like, I've sat down with mentors who've told me to close my eyes and picture my happy place, picture a beach, picture the waves coming in. And I'm sitting there with literally nothing happening. No beach, no waves, it's just blank, black. And for years, like, I thought it meant like I suck at meditating or something was wrong with me. The same thing with dreams. I barely dream, and no amount of magnesium before bed will make me dream. Maybe once in a while, and I always figured that was just how my brain was built. So it turns out it's actually the same thing. A lot of us go our whole lives thinking picture it in your mind was just a figure of speech, not something other people actually are really doing. So, and that's when it really got to me, because I've seen this strategy most performance coaches, gurus, mentors, self-help books, and podcasts rely on. And a lot of it leads into like heavy visualization, because visualization is everywhere in that world. Visualize your success, visualize the money, the house, the life you want. Especially this, like the time of New Year, during New Year resolutions, everybody's pushing it like it's some universal tool that works for anybody who just tries hard enough. And it's not that it's fake, it clearly works for some people. But nobody in the whole space ever stops to mention that a chunk of their audience, like us, are sitting there doing everything right and getting nothing. And probably walking away thinking something's wrong with them or us, when really the exercise itself just isn't built for how their brain works. If you get a chance when you get here, or you're meditating and like you're having those moments that someone's telling like picture this, do that, and you really just don't picture it, again, nothing's wrong with you. It's just you don't have that ability to really picture the image in your mind, and that's okay. So that's basically the whole module. You got built from a flat piece of paper under a month. You got dealt a hand of genetic cards that don't play themselves out in their own. You grew way more roots than you needed, and then trimmed them down to whatever you actually kept using. Even a locked-in outcome still depends on the room you're sitting in. And on top of all that, your brain's running two separate vision systems, and some people can't even picture things in their head at all. So this isn't a hype speech. This was actually true. And it's why I keep saying what I say. It was really never about what you're working with. It's about the room you build around it. So follow along. We're going to be doing more of these as I go through my studies. And hopefully you get something out of it, because right now what I'm working on more than anything is neuroplasticity, which is just repetition of the brain of doing things. And that's why I built the Forge, doing something hard every day. And it's multiple hard things at once, every day for 91 days straight. And I'm about a month in, and honestly, there's some things that have gotten less hard, like waking up early, cooking my own meals, like washing the dishes. Like I used to leave my dishes for like maybe 2 days, and it would bother me, but like for some reason I just couldn't get myself to do it. But now I've created a routine to actually get it done. So these are the things that you start to learn more about as I'm learning through this, and I hope you get something out of it, Well, catch you on the next one. And I don't know how to close this out. Done? Yeah. Let's see.